goal for today is to build a neural network that will generate names. Now we want to do this because we want to get into natural language processing. And this is a very complex topic, so we gotta start as simple as possible. And a good use case for this is generating names. So this is our plan for today. We will start by downloading a dataset that contains a large number of names. Then we need to transform the characters into scalar vectors in order to make them understandable for a neural net. Afterwards, we're going to build a neural net in PyTorch. Of course, we're going to also have to train it, and we will have to define a loss function at the end. Getting a names dataset is very simple. I've just searched for a names text file and took one that contained around 18,000 names. I put the link into the description. Now let's get to programming. The first thing I did was to import torch, random and matplotlib. Then I've imported our names text file, transformed them to lowercase and split them into a list on line break. Let's quickly check that by printing out words 0 to 10 and see if the result is what we expected. Okay, this looks good, so let's go on. Next, I've created a lexicon list which contains all 26 letters of the alphabet plus a dot that will indicate when a word ends. We need this because we need to transform our characters into scalars and then into vectors to make them understandable for our neural net. So what I'm going to do now is create a function that transforms a letter into a number using our lexicon list. And I do this by just returning the index of the given character inside our lexicon list. And as you see, this also works just fine. Now, in order to be able to train a neural network, we need to have inputs and outputs. One way to frame this is to set the desired output for every given character as the next character that follows. And this is exactly what we're going to do now. First, we create x's and y's. Then we loop through the first word. Later, of course, we will loop through every word. Create a list of our word and add a dot to indicate that the word has ended. Then we will loop through our list beginning at index 0, zipped with the same list again beginning at index 1 to always get the first char into x's and the second char into y's. By the way, Python automatically crops both lists into the same size if we zip them, which is why this works as simple as that. Let's quickly try out if this works. We're going to print out x's and y's for each character in our first word. And we see that we always get a given character in combination with the following character, which is exactly what we wanted, so that also works just fine. Now we need x's and y's to be numbers and not characters, so we'll just apply our toNum function that we defined earlier. You see that it now returns the indices of the characters in our lexicon list, just as we expect. Next, I'm transforming x's and y's into a tensor and perform one hot encoding on them. This turns all of our numbers that represent the index of the characters inside our lexicon into vectors of 27 elements, where only the index of the character we want to represent is set to 1 and all other indices are set to 0. Alright, that was our preparation for the neural net. Now let's get to actually building and training it. We're going to start by initializing a simple neural net with 2 layers. Important is that the input and output shape of the network as a whole is 27 for our 26 characters and the dot that indicates whether a word is ending. We add a parameter that will store our training progress and just progress through our layers in the forward pass. By the way, you see that I'm using the value activation function for our first layer. It could of course also be 10h or some other function. This doesn't really matter at this stage. But if you look closely enough, you can see that I didn't define an activation function for the second layer. This is because we need to write our own code for this, and we will do that within the training function. So let's dive right into it. We want to be able to give it a list of words, then we need a number of iterations, and of course the learning rate. Now first we're going to copy paste our character to scalar vector code from before and remove the y encoded list because we actually won't need it. Next, we're going to set up a training progress list in which we will store the loss, and then we're going to loop through our iterations. The first thing we have to do here is to reset the gradients of our network, because we just want to adapt our weights and biases looking at one respective iteration at a time. And if we didn't do this, we would always also have a look at the loss of the previous iterations. Next, we're predicting the outputs for our X encoded list. Now what we actually want to predict with our neural net here is a list of probabilities for the next character given the current character. In order to do that, our activation function for our output has to be softmax, because it transforms our values into probabilities for any given value inside our output vector that add up to 1. Now we get to the last function. Let's think about it first. The output of our network for any given character will be a vector of 27 elements that represent the probability for the next character being the one at the given indices. Wise tells us the ground truth about which character came next for every character in X's. So what we will do is just looking at the index of the correct next character for X, which we find in Wise. We always want that value to be as close to 1 as possible. Therefore, we need a function that gives us 0 for x equals 1 and a high number for x equals 0. And this is exactly what the negative log function does. Let me paste and plot it real quick for you, and let's have a look at it. You can see that our loss would grow the more we approach to 0 and shrink the more we approach to 1, which is exactly what we need. Now we have to implement this into our training function, and the code looks like this. We want to look at the value of our probabilities for the correct next character whose index is represented in Y's for every value in X's. Then we want to have the negative log, and our loss will just be the mean of this. And that was the hardest part, I promise. Okay, now let's get back to the easy stuff. We just want to store that loss on our training progress list and backpropagate through this to get the gradients for all of our parameters. So after we call the loss.backward function, we have to adapt the values of our parameters by the respective gradients, by looping through them again and changing their data attributes. By the way, make sure to write plus equals to p gradient, because otherwise we would reset the values of our parameters. And of course, we also have to multiply this by the learning rate. Alright, now after we finished our iterations, we set self.training progress to training progress. And the last thing we have to do now is actually initialize a neural net, and we're done. Of course, we do this by creating an object that we name net that will be equal to neural net. Alright, so far so good. Now let's train it and have a look at the progress. But before that, let's make sure that we train it on every word in our list and not just the first word. Therefore, we just say net.train and use our words list. Then we go for 100 iterations in the first trial, and we set our learning rate to 1. Now after we finish training, let's have a look at the actual training progress. Cool, we can see that it actually seems to have learned something. But of course we need to try it out in real life now. So let's get it to actually generate names for us. To do that, I'm creating a char string that will store the generated characters and a number ix initialized at 0, which will represent the index of the next character we predict in our lexicon list. Then we loop through the number of characters we want to generate. The first thing we do here is to one-hot encode ix to a vector of 27 elements to make it understandable for our neural net. Then we feed it into our net, apply the softmax, and generate a new ix based on the probabilities our neural net has predicted for the next character. To achieve this, I'm using the random.choices function, and I use the probabilities list we just generated as weights. Once we've done that, we append the character that we've just produced at index ix to our chars list, and finally split it on our dot after we're done to get a list of generated words which will be names. Alright, so now comes the moment we've all been waiting for. Let's run it. We see that it has generated some names, also the quality is not that good yet, and this is because we only take the last character into consideration to predict the next one. To make really good models, you need to take much more into consideration, but what we have achieved right now is we have created our first generative model that is able to produce text. And we will continue from here to build much more sophisticated models in the future. So stay tuned everybody, and thank you for watching.